Okay, hello friends, welcome to my lecture. Today I'm going to show you how to analyze a given electrical circuit by using mesh analysis. So mesh analysis, it is a general method for providing an electrical current which is flowing through a given branch and a voltage group across a resistance just by using what? Mesh currents. And here it is. There are three main steps to analyze mesh currents just for providing a current which is passing through a given element and a voltage drop across a resistor. So first we have to assign a mesh currents for each n loops. So if we have n loop, we have also what? N mesh currents. And the second step here it is, we are using KVL method. That means KVL is a law which states that a summation of voltage across a closed loop is 0. Okay, so we can use what? Both of two basic laws that are KVL and what? Ohm's law. The third step is just evaluating the mesh currents just by using what? Simultaneous equation. So if we have n number of loops, we have what? N number of simultaneous equation for analyzing mesh currents. So here it is an example. So here the question says for the given circuit, find the branch current I1, I2, and I3. Here is a branch current means a current which flows through what? A given branch. So we have three resistors here. So we are going to find a current which is flowing through this 5 ohm resistance, which is I1, and the current which is flowing through this 6 ohm resistance, which is I2, and the current flowing through this 10 ohm resistor, which is I3. So we are using a mesh analysis for providing these branch currents. So the first step is we have to assign what? The mesh currents. Yes. So as you see, the mesh current is already assigned as I1 and I2 since we have two closed loop. So we have two mesh currents. So now let's apply KVL method for each loops. So if we apply KVL for the first loop, that means if we apply KVL method, that means a voltage across a closed loop is what? 0 is. So if we take a summation for this loop, minus 15 volts, since a current is entering in a negative terminal for this supply voltage, plus since this mesh current is equal with this branch current, so we can what? Just multiply this, the value of resistance, which is 5 ohm, times what? I1. That means a mesh current which is flowing through the first loop plus 10 times I3. Yes, so if we apply KCL as this node, I3 can be calculated as I1 minus I2, and I1 is which equal with the mesh current I1, and I2 is equal with the mesh current I2. So we can just use I1 minus I2 instead of what? I3. Okay, I2 plus 10 volts, since for this supply voltage a current is entering in a positive terminal, 10 volt equal with what? 0, since KVL which states that a summation of a voltage across a closed loop is what? 0. So if we simplify this equation, we can obtain what? 5 plus 10 I1, we can what? Obtain 15 I1. 15 I1 minus 10 times I2, which is 10 I2 equal with 5. Yes, so we can just simplify this equation just by dividing both sides by 5. So we can obtain what? 3 I1 minus 2 I2 equal with 1 is. So we can take this as equation 1, and if we apply Kirchhoff voltage law across the second loop, we can obtain what? Since this current is entering in a negative terminal for this supply voltage, so we can have minus 10 volt plus 10 times the current which is flowing to this circuit, flowing through this 10 ohm resistance, which is actually it's a negative of I3s. So we can take the negative of this current just by multiplying negative both sides. So we can obtain what? I2 minus what? I1. So I2 minus I1 plus the voltage drop across this resistance is 6 times a current flowing through this resistance, that's I2, but this branch current I2, which equals what? The mesh current I2. So we can simply use what? The branch current I2, 6 times I2 plus 4 times I2 equal with 0. So this is KVL for what? The second loop. So we can just simplifying this equation, 10 times I2, which is 10 I2 plus 6, 16 plus 4 is 20, yes? So this can be written as minus 10 I1 plus 20 I2 equal with 10. Okay, so we can just further simplify this equation just by dividing by 10 both sides. So if we divide this equation by 10, we can obtain what? Minus 10 over 10 is minus I1, is minus I1 plus 2I2 equal with 1. Okay, so now we have two simultaneous equations, so we can obtain the value of I1 just by using what? Substituted, yes. So if we take the summation of these two equations both sides, we can have what? Minus 3 I1 plus minus I1. So we can have what? 2 I1, okay, plus 2 I1 plus minus 2 I1, that's 0, and 1 plus 1, which is what? 2. So we can have this equation, yes, if we take a summation for these two equations. So if we divide this equation by both sides, we can obtain what? The value of I1 as 1 ampere, yes. So the mesh current, that means a current which is flowing through the first loop, can be obtained as what? 1 ampere, okay? 1 ampere. So we can just now calculate the value of a current which is flowing through second loop just by using either of these two equations. So if I use the first equation, so we can have 3 times 1, which is what? 3 minus 2 times I1, which is what? 1, okay? So for this equation also, I1 can be, actually I mean which is I2, yes, I2. So I2 can be also calculated as, if we take a subtract of 3 both sides, you can have I2 equal with 1 ampere, okay? So now we have calculated these two mesh currents. So now we can just simply find the branch current, which is I1, I2, and I3, just by using what? This mesh current. So I1 can be obtained as, or can be obtained as I1. Okay, this branch current I1 is equal with what? The mesh current I1. So we can have what? 1 ampere. 1 ampere. And the second current which is flowing through this 6 ohm resistance, that means I2, can be calculated as this by equalizing the second mesh current, which is what? I2. So which is what? 1 ampere. 1 ampere. And to find the third current, which is a current flowing through this 10 ohm resistance, just by what? Taking KCL as this node. This KCL, which states that the current entering into the node equal with what? The current which is what? Leaving energy. So IC can be simply calculated as what? Take a subtraction between these currents. So I1 minus I2 equal with, so I1 is calculated as 1 ampere and I is also calculated as 1 ampere. So if we take a summation of this value, we can obtain what? 0. Yes, so this indicates that there is no flow of current across what? This resistance. So this is the end of my today's lecture. So if you are new for my channel, please try to like, share and subscribe my channel.